In the next few videos, we're going to be talking about class objects or classes and the definition of classes and how they are used to create objects. And I think we talked a little bit about it before that C also had objects, but that was anything that you could create in C. That was a variable, anything at all, an integer, a character, any of those things were considered to be objects. Well, we use the term a little differently now, and we're talking about object-oriented programming and getting into more detail. An object is when we instantiate a class, and a class is just a description of what a object will eventually look like should we decide to make one. Now, all this object-oriented business, that's called a modular programming method. But C++ will support both procedural and modular methods. It does, however, make it easier for you as a programmer to implement and use modular methods. Though I want you to know that everything you learned in C and C programming still does apply. But there's more. C++ supports and encourages modular methods. Again, that makes them easier for you to implement so that you can use these modular methods without going out of your way. Actually, the compiler will enforce some of these things for you if you let it. There are switches and things that you can set on a compiler to make it not check these types and do various cast checking and things like that, but you don't want to do that. I mean, that defeats the purpose. That's only if you need to code something in C using a C++ compiler. So here in the procedural world, you would decide which procedures you want and then get the best algorithms that you can find. And that's normally what we have been doing for many years in programming. You would decide top down, step 1, step 2, step 3, what do I need to do to perform a particular task? And that's a procedure. You have a process that you go through, a procedure, one thing after the other. And that's essentially what we've been doing all these years. And we tell the computer what to do first and second and third and so on. Now, object-oriented, though, that's a whole different way of thinking. In object-oriented, we decide which modules we want. We have to think of them as kind of different containers, almost black boxes that do whatever they're going to do. And then we partition the program into these modules so that the data that is necessary to be used by a module or an object is hidden inside that module. Very little information is really going to be available to the outside world. This is a whole new way of thinking, and this is the object-oriented programming paradigm that they call it. And this allows objects to interact like they would in the real world. If you have two cars on the road, they interact in certain ways. They don't interact by their pistons connected to one another, or carburetors, or fuel injection, or any of those internal things. They connect to one another by turn signals, which are, of course, controlled by the driver, the operator of the thing. So those are external or public bits of information about the object, or in our case, about the car, that are shown to the world and known to the world or made public. Other private things the world doesn't need to know about, but the vehicle itself, the car itself, or the operator of the car needs to know a little bit more. So these objects will be self-contained objects and will only interact with each other in very specific ways. When we have a class object, when we have a class created, the class will contain both the data inside the class, the members, they call it, and the functions, which are known as methods, that will work on that data. Now, we saw something very similar to this when we had our structures back in C, our struct. A struct with functions in it is very much a class. That's a class definition. We have some new things, though. We can make some methods public and some methods private. And there's even a protected method in data, and we're going to talk about all of these as we go. But public methods are, like I said, like the turn signals, things you can see from the outside. Private methods would be only usable by other methods within the class. Some data variables, certain things about the object, are available to the public to be read even to be set and changed, and some of those data are private as well, where we only want the class to be able to deal with those variables. Obviously, as we get through this, as we look at data members and member functions and methods and all of that sort of thing coming up, we're going to get into all this in detail. But you need to really start thinking about this, that object-oriented programming, you're going to be creating self-contained modules. Those classes will be able to communicate with one another through specifically defined methods and public members of data, and those are called interfaces. When one class can communicate with another, or a class allows itself to be manipulated in some way, that's through an interface. And we will show that we can have multiple interfaces to a single class. So that's going to be kind of interesting. Hang on for the ride. It's going to be a good one. And we're moving right along to the next video. Okay, we're talking about classes, and now we're going to talk about members in a class. These are the variables, these are the data that live inside an object. Just like we used to have variables and data that lived inside our C programs, now they are within the various classes. It just kind of keeps them separate from one another, and it makes it easier for us to think about, and makes it easier for the compiler to understand what we're trying to do and when and where, and how to maintain some separation of these items. The members of a class have what's called an access specifier. That's a new item, and you can see that there underneath the class name. This is what a definition looks like. Here we're going to make a new class. This is the name of the class, kind of like the tag to a structure that we used to have, our open brace, and this is a new thing that we haven't seen before. This is an access specifier, and this is the first one. It has a colon at the end of it, not a semicolon, but a colon. And then this will be the first member that is corresponding to that access specifier. And then we can have another access specifier, another colon, and then more members as we go down through here. This is our class definition. If we're going to instantiate or create any of these classes and create an object, it'll be right here. And then, of course, this creates a new type, just like an integer, character, float, something like that. So we will be able to make new objects later on, and you'll see, of course, how we do that. But we can have the object immediately created right here, or have a new one. This actually takes up memory. This, of course, does not. This is just the definition of what a class looks like, should we ever actually make one down here. So classes can have data or variables called members. Members can be private, public, or protected, and that's the access specifier. You'll see the word private or public or protected in that access specifier with a colon after it. Now the members that are there, they can be any type. They can even be other classes. They can be integers, floats, characters, all of those good things, but we have all kinds of opportunity to create new types of variables. That's really what one of the great things about object-oriented programming is we can create these new types, and when we create them, we can create the rules that say how the types can work, what you can put into them, what you can take out of them, how you can convert them and do casts, type casts from one thing to another. Remember how we used to cast an integer into a character, and you could possibly lose some data because an integer was normally twice the size of a character. Well, when we create these classes, we are creating new types, and we can specify how all of that works. And you're going to see a lot of that as we go through our fundamentals. Not all of it, but I guarantee you that I'll introduce you to some of the other type creation things that we can do. And that's what this is right here. When we make a new class, we're making a new type. Now here, let's make a C rectangle. This is a new class definition, and it's called C rectangle. That's kind of a convention in the OOP style, is to have a capital C in front of that name so that you see that this is in fact a class definition. Now down here, this will be the real object that takes up memory, a rectangle. But here, this is what the class definition, the class name is up here. Now only C rectangles, other like rect here, can see the X and Y. So when rect is created, it knows that it has an X and Y, but nobody else is allowed to know that, because when you start a class declaration like this, the first default set of access specifiers is private. So int X and Y here are private. Nobody can get to them. We have to specify that we want some things public. And when we say public and a colon, now this function set values, which takes in two integers, is part of the CRectangle. It is a function within the CRectangle class. And this is really called a method. This is a definition of a method. We haven't a declaration, I should say, of a method. We will define the method in a little bit and actually say what does set values do for us. But right here we are declaring set values as part of CRectangle. And here we make an integer called area. Area will return an integer, if I can read my own code, and it takes nothing in. So there's a void parameters to area. Area is another method which can be used to return information about a rectangle. And as you can probably read ahead, we will teach area how to calculate the area that this rectangle covers. Now again, anybody that can get to rect can see this set values and area method. They can use it out of this rectangle. And rect is an instantiation of a class called CRectangle. See, it's not too difficult, huh? Well, let's keep right on going and look at some more of this in our C++ Fundamentals video series. Hi there, welcome back to our video series on C++ Fundamentals. We are going to take a look at a actual little program that's going to do something very simple, but a lot of the pieces that we've already talked about are in there. And we're specifically wanting to talk about the members that are inside of a class, but I want to show you that in an actual little program that's going to do something. So we're over here in our Visual C++ 2005 Express Edition, which we got as a nice freebie from Microsoft and got it all installed and updated. And you did that way back in chapter 1 and back at the beginning of our video series. So let's just go line by line down through our program and take a look at it. The first line is something that Microsoft likes. That's our standard AFX.H, and that'll need to be there. If you don't have standard AFX.H as one of your early lines, the compiler will be glad to complain about it, and it will prompt you, did you forget to put this line in? So just put it in there. Then we include our IO stream, because we're going to be writing to the screen in a little bit, and that's there. And then we're going to set up to use a STD, the standard library namespace. We'll talk about namespaces later on in the video series, but basically this says that we want to gather a group of functions and methods that are out there and different kind of definitions and use them without having to call up std : all the time. So it says that we're using the standard namespace. Now here we're going to make a rectangle, and I use the class name CRectangle, and you can see that right there with the capital C in the front of it, and that just says that that's the name of my class. That doesn't create anything. Remember, this is just a declaration. We're not actually creating the class yet. And you know, by instantiating the class is when we'll actually create one. So here we just want to say what the class actually is and what's in it. We're going to have two integers which are private, and that's h and w. That's going to be height and width of our rectangle. And I'm thinking about building a deck on my house, so that's why I've put this little thing together, just to do a quick area and know how many square feet we're talking about. Here we have a public access specifier, and that says that these two items, anything after the word public : will be available to anybody that wants to use them in the rectangle. The H and W are only available to the CRectangle class, other members. So H and W could only be used by set sides or area to be able to do any work with them or touch them at all. Set sides, this is a declaration of the little function called set sides, the method, because it's a method that we can use with this class, and it'll take in two integers, int, and that's the interface to set sides. It'll have to take two integers or the compiler will complain about it. Here we have an int area. This is another definition of a function. And here is our actual definition of the function right there. That's the code that makes it up, because there's the braces that we need to contain the contents of the function itself. This is called an inline function or method, an inline function. The rule of thumb for an inline is that it should fit on one line and be a very simple return like that. This can save you some function called overhead by putting this in here, because it will be included right in the class as an inline function definition. So that's our little area function, and it will return an integer. We see the int there. Notice it set sides is a void return. It doesn't give anything back. Area will return an int, and what we'll return is the h times the w, the height times the width. And that's the same h and w that were defined up here. All right, straightforward. Now we're going to come down here and we're going to actually define the set sides method, and that method, which is referred to up here as part of the CRectangle class, now has to, it was declared up here, now it has to be defined down here. We have set sides. It'll take in integers a and b. This looks pretty normal to C programming, right? We have our open brace, and then we're going to say that h is equal to a, this incoming integer, and w is equal to b, this incoming integer. So these h and w's are our two private h and w's up here that are part of CRectangle, and we can see them because we also are part of CRectangle. Set sides is a method within CRectangle. All right, and here's the closing brace on the CRectangle. Now that's enough for right now. I'm going to start another video so that we don't make these too long and boring. And then we'll talk about main and how we actually use this class, okay? So just skip over to that one, and I'll meet you right back here in a second. Welcome back. I told you we would pick this right back up where we left off. We have our CRectangle class defined. We have one of the methods, set sides, defined outside the class or right after the class. And when we put the set sides name here, we had to use CRectangle : as part of the name when we're defining the function. That's so that the compiler understands that we are defining this function right here, which is within this CRectangle class. That way we get the correct scope and put it all together into CRectangle : set sides. So we are now actually defining this particular function. Okay, now main down here, we are going to first of all make a new rectangle right there, RECT, and that is our rectangle, and it is one of these, CRectangle right there, and that's our class up here. So you can see that we have created a new class. We've created, in addition to a new class, a new type where we could have said int and something, ABC, or some other name down here. We can now say CRectangle and use that just like any other base type that is part of the language. So here we have CRectangle, rect, that creates a new rectangle, and so this thing is now taking up memory. It's taking up enough memory to contain h and w, and set sides, this is just going to be a pointer to this function, which is defined over here, and then this function, this little return and multiplication, will be inside the class as well. So here we have our new rectangle, and now we're going to use one of its methods. And we use, just like we would in a structure, we use the variable rect, or the object, with a dot nomenclature right there, and then there's the method set sides, and we're just going to hard code some values in. The deck I want is 12 feet by 24 feet, so I'll use 12 and 24 are our two sides for our rectangle, and that sets the 12 and 24 into h and w of rect. So we couldn't get to h and w directly because they're private, but we can get to them by using this method called set sides. And method will only take in two integers, and it's very careful about what it does. This way we can get to these data values inside this rectangle of the real object here, but we have to go through this method. This is modular programming. This is what's different about modular programming than procedural, where we would just say rectangle.h is this and w is that and so on. We don't have the kind of control and protection that we have that we pick up here in object-oriented programming. So this is what it looks like. There we'd call this method set sides, and notice when I hover over it, it shows me the interface for set sides, that it takes in two ints. And if I had more than one way of coming in, maybe I could take in doubles for being able to have floating point values. There would be a small list here of all the different possibilities of what I could put in there. Now let's get something back out of the rect object, and here we have cout, that's our console output, and that's part of our output stream, and standard cout, and you can see the definitions pop up there. It's in the standard namespace, that's the leftmost, and then there's 2 colons, and then the class is the OStream std, and then the cout is the actual member that we're using in there. So we have our cout. This is the send to. We're sending this data out, the cout, giving cout. So here's our text, real simple, area, and then we'll call another method, the rectangle.area method, and that's this method up here, which is our little inline, and the information will be calculated in height times width, which are already here in our private integers, and then that number will be converted by cout, because cout understands what to do with an integer, how to display it properly, and then we'll stick a new line at the tail end of it just to get down on a new line. And then we'll get out of our program and return 0. So very simple, but all of the things that we've already talked about in classes are there. And this little classes 0203 CPP will be available to you as part of the video series. It'll be on your disk or available on the site, so you can grab this if you don't want to type it all in. I would recommend you type it in, because a few typos here and there are a good learning experience, but it'll be available to you. So now let's run this and see what it looks like. I'll do a Control F5, and there we go. Area is 288, and since I did Control F5 without debug, I have to press any key to continue, and we saw that back in Chapter 1, and that is our first class. And declaring the class, declaring a method that is within the class, and then defining it, and then actually doing something with our new class, creating it, and then using it, and then when we hit the return, garbage collection will be done, and this rectangle will be cleaned up. Okay, so that's the end of our first class. Good job. We'll move on to the next video. Hello again. Welcome back to C++ Fundamentals. We want to talk for just a minute about something called nested classes. Since this is C++ Fundamentals, I'm not going to take you deep into the details of this because it can get a little bit hairy. But let's just try to understand. I want to help you understand that there can be classes nested within other classes. They can be defined and declared down inside another class where it makes sense. They're also known as member classes, because these nested classes or these subclasses are defined in the same places that you would find the other data members of a class. Let's take a look at an example here for just a minute. We'll get this out of the way. That's just some things for Microsoft, our AFX, so we'll get rid of those declarations. Here we have this class surround, and you see that the compiler helps us out by reminding us the name that we can already see. So there we have class surround, and here's our public area. These are going to be the public definitions and declarations of this class so that everyone can see them. And now we're going to create another class inside here called first within. It will have its own private d variable integer that if we hover over that, we see it's an int, and it is within first within, which is within surround. So we have surround double colons first within double colons d variable, but it is private to first within. Now here is the constructor for first within, and we're going to see constructors in more detail in a couple of chapters, but basically this is the function that is always run first when we create a new one of these classes. So this will construct any local variables and things like that we need, and the way we know it's a constructor is it has the same name as the class. So we have class first within, and then we have a function being declared in here called first within. Same name means that it's a constructor for the class. Then we have another little function here called var, just to kind of stick something in here. It's a constant function, and it will return this d variable that's up here in the private area. So real simple. But so this is a public class defined as a member to this surrounding class out here. Now here, this is the private area for this class called surround. All right, we had the public area here. Now we've gone private with an access specifier to show that we're changing how we get to things. Now down here we have another member class called second within. This class will have its own private d variable, which has nothing to do with the one that's up here. Different classes, they'll have different names. Here you can see surround second within d variable versus surround first within D variable, different places in memory. And here's our public section for the second within class, and it has a second within constructor function as well, defined or declared here but not yet defined. And here's another var function, and it's another constant function, and it'll also return this other D variable that's right here. This is the one coming back. By having these classes within each other, we can kind of subdivide and compartmentalize the program so that in our case, a first within only makes sense in the context of being inside the class surround. A second within only makes sense being inside the class surround, but we don't want anyone else to be able to work with it, so it is private, and that changes the access between these two members. Public members we can get to from the outside world, but no one will be able to use this second within class unless they are within the class surround. So people from the outside world, other functions and methods and that, can't even see this. They can't deal with it any more than they can deal with anything else that is under the private access specifier. But things within the surrounding class, like first within, can work with second within for the public sections. Again, second within gets to decide who can see things outside of it. So this D variable being declared private within second within says that only second within can work with it, and things that are defined within the second within function. Now, if that's not truly confusing, all we're trying to say is that second within and first within are separate from one another, and second within gets to say who can see its inner variables. And in this case, since this is set private, only anything within second within can work with it. First within cannot touch this variable. It has to rely on another method to deal with it, a public method like this var function down here. All right. Hopefully you're confused to a higher level at this point, but the main point, the fundamental that I want you to understand when you're reading other code and other tutorials and things like that, is that you can have classes defined within other classes if that helps you subdivide your program and make it logically make more sense to you. All right. Hopefully we've done that for you. Onward to our next chapter.